Okay, so here we have a AC series circuit. Remember, we had steps that we do. Step number one, what do we say? Ensure you are in phasor form. So we look at our voltage, 35 volts at an angle of 15. Is that my phasor form? Yes, it is. So check. Number one is good. Number two, find X of C and X of L. Okay. X of C equals what? 1 divided by 2 pi FC. X of L is equal to 2 pi FL. Okay. So we punch the numbers in our calculator, 2 pi times my frequency, which is 2 kilohertz, so times 2K, times my capacitance, which is 22 microfarads, which is 22 exponent negative 6.
I didn't do the 2 pi. I substituted the 2,000.
Nope, you got to do 2 pi. The only time you substitute for the whole thing is when I give you omega. If I give you omega in phasor form, that whole number goes in for 2 pi f. Here, I didn't give you that. I gave you the frequency, so it's 2 pi times the frequency. So when I punch that in my calculator, I'm going to ever so gently line that out, and I should have gotten X of C, 3.617 ohms at an angle of negative 90. Same thing, I punched 2 pi times 2K hertz times 3 henries. And when I punch that in my calculator, ever so gently line that out, I should have gotten
90.
37.699 K ohms at an angle of 90.
Well, I just did the X of C.
Yes.
And I got 3.617 at an angle of 90.
How'd you get an angle of 90?
I did 2 pi times 2,000 times 22 exponent negative 6 angle negative 90.
Nope, you don't put the angle on there now. You don't put the angle on until you get your ohms.
Oh, okay. So
once you get your ohms, then you put the angle of negative 90 on there. Because capacitors are always at an angle of negative 90 once you get your X of C. There's no angle on my actual capacitance. When I get my capacitive reactance, which is X of C, that's when I have to put the angle on. And I always put negative 90 on my capacitors, and I always put positive 90 on my inductors. When you're figuring these out, there's no angles involved here. You put the angle on after you get the answer. Okay. Then step 3 said put angles on everything. So I already put my angles there. The only thing I need left is my resistor. And I know resistors are always at an angle of 0. So bam, I'm done with that. Step 4 says find Z total. So all I do is add them all up because it's a series circuit and get my Z total. And Z total, when you did that, should have came out to 37.725 K ohms at an angle of 87.221. Right? No, 721. Sorry. 87.721. Can't read my own writing. Okay. Step 5 tells me find I total. I total, found the same way we've always done it. E total divided by Z total. When you do that, you should have got 927.761 microamps at an angle of negative 72.721. So my last step, step 6, is find voltage drops. And then all I do is I either use my voltage divider rule, or I take my impedance times my current, impedance times current, impedance times current, and get my voltage drops. And we've already went over them, so I'm not going to write them on the board, but I will say them in case you want to go back and look over them. VR1 was 1.392 volts at an angle of negative 72.721. VC1 was 3.356 millivolts at an angle of negative 162.721. And VL1 was 34.976 volts at an angle of 17.279. So now we have an AC parallel circuit. So the first thing we know is we know the voltage drops on these are all going to be the same because voltage is constant. But we follow the same steps. First step, ensure we are in phasor form. 20 volts angle 35, that's phasor form, so I don't have to do nothing. Step 2, find X of C and X of L. So we're going to punch in the same way, 2 pi times 15K times my capacitance equals shift reciprocal equals, that's going to give me my capacitive reactance for my capacitor. 2 pi times 15K times 1.5 henries gives me my inductive capacity or my inductive reactance, and then I'm good. So this one, if you punch it, you get 1.294 K ohms at an angle of negative 9. Now I ever so gently line out my 8200 pico. And this one, 141.372 K at an angle of 90 for my X of L. Now line that out. Step 3 says I put angles on everything. Well, the only thing without an angle is my resistor. So I'm going to put a 0 in. Step 4, find Z total. I find Z total in an AC parallel circuit the same way I found it in a DC parallel circuit. 1 over R1 plus 1 over my X of C plus 1 over my X of L equals my Z total. The only difference is when I do parallel AC, when I punch them in my calculator, I got to put 1000 at an angle of 0, all in parentheses, and then hit my shift reciprocal. That way I don't just shift reciprocal my answer. Then I hit plus, open my parentheses again, put 1.924K at an angle of negative 90, close my parentheses, shift reciprocal, plus, open my parentheses again, 141.372K at an angle of 90, close my parentheses, shift reciprocal, then I hit equals, I hit shift reciprocal again, and then hit equals, and I get my answer. So my Z total answer, you should get when you do that up, 793.986 ohms at an angle of negative 37.442. Okay. Step 5 says find I total. Well, we do that the same way we've always done. E total divided by Z total gives me I total. When you do that, 25.190 milliamps at an angle of 72.442. Now, this is where my last step is going to change because I'm not going to find voltage drops now, right? I'm going to find current through each component. So I'm going to find IR1, IC1, and IL1. Because I know the voltage drop across each of them is going to be 20 volts at an angle 35 because it's a parallel circuit and my voltage stays constant. So all I got to do is take the voltage divided by the impedance, voltage divided by the impedance, the voltage divided by the impedance, and I get the current through each one of my components. So again, I'm not going to write these all down because I know they're going to be hard to see, but I will tell you what they were. IR1, 20 milliamps at an angle 35. IC1, 15.456 milliamps at an angle of 125. And IL1, 141.471 microamps at an angle of negative 55. And then I just add them up, add these three up, and make sure I get my I total. Same thing I do in my series circuit when I add up my voltage drops, make sure I get my E total. Here I add up all my currents and make sure I get I total. Everybody good?
Yeah.
So now you got a parallel circuit and you got a series. So here we have a series parallel circuit. So we're going to start out the same way. I want to make sure my voltage is in phasor form because I know it's got to be in phasor for me to solve the circuit. So I look at it. 60 volts, angle 0, that's phasor, I'm good. Next it says find X of C and X of L. Well, I got 300 ohms and 800 ohms, which means I already gave you X of C and X of L. So you don't have to find anything because they're already in ohms. Step 3 says put angles on everything. So I'm going to put angles on everything. My inductors, angle of 90. My capacitors, an angle of negative 90. My resistors, angle of 0. So now I got angles on everything. Now I'm going to solve it just like I would do my DC series parallel. I got to get it down to a simple series or a simple parallel circuit in order for me to solve it. So I go farthest away from my source. I got an 800 ohm inductor, and that's in series with my 500 ohm resistor. So how do I find Z total in a series circuit? I just add them up. So all I got to do is write 500 ohms angle 0 plus 800 ohms angle 90 equals, and when I do that out, I should get 943.398 ohms at an angle of 57.995. And just like I did in DC, I'm going to circle it because that's important to me. Then I'm going to redraw my circuit. Put my resistor, my capacitor, 60 volts, 0, 350 ohms, angle 0, and 300 ohms, angle negative 90. Well, now I combine these two. Well, when I combine them, where do I put them? Well, these two have 2 points in common with that capacitor, so I'm going to put it in parallel with the capacitor. The only difference is instead of making it a component, I'm going to put it in a box. That way I know I have two different components here. They're not the same. I'm going to write it in 943.398 ohms at an angle of 57.995. So now I'm going to look at it. I still have a series parallel circuit. So I start farthest away. 943.398 ohms at 57.995 is in parallel with my capacitor. So I got 300 ohms at an angle of negative 90 in parallel with 943.398 ohms at an angle of 57.995. Remembering when they're in parallel, I must put everything in parentheses before I hit my shift reciprocal. And when I do that in my calculator, I should get 400.025 ohms at an angle of negative 77.005.
I did not get that.
Did you put everything in parentheses in your calculator?
Yeah, I'm doing it again now, just
So
to
what?
see if I fingered it or.
100. Let me make sure I did it right.
I got a different number this time. I got your number.
Actually, it's 400.25, not 0.025. I did mess it up. It should be 0.251. Or at least that's what I got. Is that what everybody got? 400.251?
Yeah.
What's the angle? I can see it.
Angle is negative 77.005. See, so I couldn't even copy from my calculator to the paper. Oh, no, I actually had it right here. I just couldn't copy it right down to the next one. Way to go, dummy. Anyway.
You're
So
recording,
now
right?
yes. So now I'm going to redraw my circuit again. Okay. I got my resistor. And when I cram those two together, they have how many points in common with my resistor? Just one. So it's going to go in series. I'm going to put my box here. 400.251 ohms at an angle of negative 77 point, and I know you're probably not going to be able to read this, 005. This one's 3, right now. This one's 350 ohms at an angle of 0. So now I got my series circuit, 60 volts, angle 0. So I'm going to get my Z total. All I'm going to do is add these two together. So 350, angle 0 plus 400.251, angle negative 77.005. And when I did Z total, I got 587.781 ohms at an angle of negative 41.540. And it might be a little bit different because I had 400.025 in there for some reason. I don't know why. So you guys may get a little bit different number. Shouldn't be off by much. Then I'm going to find my I total. E total divided by Z total. 102.079 milliamps at an angle of 41.540. Now I'm going to go back and I'm going to get my voltage drops for both of these. I'm going to add up them voltage drops. I'm going to make sure they equal 60 volts at an angle of 0. Okay. For my resistor, I should get 35.728 volts at an angle of 41.540. And for my box, I should get 40.834 volts at an angle of negative 35.465. Okay, and I'm telling you guys this when you go back, you can hear it because I'm running out of room to write on my board. Okay, So now I got this box. Well, oops, I forgot to circle it. I go back to what I circled. That's how I found the box. How did I find it? These two were in parallel. What's constant in a parallel circuit? Voltage. So I bring the voltage from here, which was 40.834 volts at an angle of negative 35.465. I bring that voltage back to both my capacitor and to this box. Now, since I have voltages and I have impedance, I can find the current through each one of these. The current through my capacitor, I should get 136.113 milliamps at an angle of 54.535. My current through my box, I should get 43.284 milliamps at an angle of negative 93.46. Well, now I got a box. I go back to what I circled. How did I find it? These two in series. What's constant in a series circuit? The current. So I'm going to take this current and I'm going to put it up here. But before I do that, I'm going to add these two currents together, make sure I got where they came from, which was down here. And that current was 102.079 milliamps at an angle of 41.540. So when I add those two currents, I should get that current, which is my I total. If I did, I'm good. I take the current from this box. I'm going to bring it back to both my 500 ohm resistor and my 800 ohm inductor. Then I'm going to take the current through these and I'm going to multiply it by the impedance and give me my voltage drops for these. And when I do that, the voltage drop I should get for R2 is 21.642 volts at an angle of negative 93.46. And the voltage drop I should get across my inductor, 34.627 volts at an angle of negative 3.46. And now I got voltage and current for R1 here. So I've already got that one. I got voltage drop and current for C1 here. And now I just got the voltage drops and the currents for R2 and L1. I am all done. I have all my voltage drops and all my currents for each one of my components in the circuit.